Hey there, this is lesson 15 and 16. Lesson 15, unit 1, symmetry through reflections. So what does symmetry mean? And we have looked at reflections before, so let's explore that. So let's describe some symmetries of shapes. So symmetry is basically after a rigid transformation, a figure is taken to itself. So what does that mean? Let's explore it. So here's our warm-up. Here's a segment AB, okay, a line segment. If you translate the segment up 5 units and then 5 units down, it looks the same as it did originally. What other rigid transformations create an image that fits exactly over the original segment? So let's look at this situation. I'm going to go ahead, create that segment, okay, using GeoGebra. I'm going to go ahead and use a translation, okay, because that's the example they gave us. So I'm going to translate it. I'm going to do 5 units, or I want to, oops. Oh, I see what happened there. So can I change that? Let's see. I just created the vector line. So how about this from here to here? Okay. So see the line segment moves up and to the right a little bit. Now what if I did another translation, except this time I selected this line segment, and then I went back down to the left where we were originally. Do you notice how line segment AB and line segment A double prime, B double prime map completely onto themselves? That's what it means to be symmetric. All right. The figure in question, the line segment, maps back onto itself. Now, what other transformations it asked, right? So let's try to figure that out. What other transformations could we have done? Um, what about rotation? Okay, let's look at rotations. So transformations, rotate around a point. Let's click this. Here's our point of rotation. If I go 45 degrees, do you notice how the image created by that rotation is not mapping onto AB? What if I picked another rotation, except this time instead of 45, how about we do 180? See what that would look like. Whoa, doesn't land on top of it, does it? Doesn't map on to AB. Let's try again. Let's try a different rotation. How about we go from here around point C, but this time we, like a skateboarder, we're going to pull off a 360. Ah, do you see how this became B prime here and A prime here? Okay, it's sub 2 because this is the second time I've rotated this object, right? So this was the 45-degree rotation around point C. This was the 180, but notice the 360 literally takes AB, rotates it all the way around to where it lands perfectly on top of the original line segment. So that's what they were talking about. Is there any single rigid transformations that do the same thing? Oh, we just did it. We just did a rotation of 360, right? Now, I think they were saying transformations here, so they might have been implying a sequence. If they were, you can always move something with a transformation, either by translation, reflection, rotation, and those would preserve rigid motion, but to map it back onto the original, that may take a sequence. So what is symmetry? The simplest way of saying it that I've normally explained it to most people is if you can fold a figure um, in a location where one side will map perfectly onto the other, that would work. That would be a line of symmetry. Okay, so a line of symmetry for a figure is a line such that reflection across that line takes the figure onto itself. All right, so if you were to fold a piece of paper in the right spot, that piece of paper, one side will map perfectly onto the other, right? And we've all done that. This figure shows two lines of symmetry for a regular hexagon, six-sided gon, right? And if you were to fold it, it would line perfectly up onto itself. The letter I is symmetric. If you fold it straight down the middle, either horizontally or vertically, one side will map onto the other. If you look in the mirror, right, and you put your hand right between your face, okay, that is a line of symmetry. I mean, it's not perfect. There's always those, genetic aspects of nature, but for the most part, a lot of, I think most creatures, most biological creatures, have a line of symmetry. Okay, and that always amazed humans, philosophers, and mathematicians for thousands of years. So even living creatures have line of symmetry. Now, using the GeoGebra link, so I'll use GeoGebra here. Determine all the lines of symmetry for the shapes. Record your findings. So reflection symmetry. If a figure of reflection symmetry is there a reflection, it takes the figure to itself. Let's see. So we got a kite. Okay. Let me go ahead and see if I can create a kite real quick using good old GeoGebra. And I always highly recommend that everybody tries their best to. I'm going to go ahead and use a grid. I'm going to take off the axes. I don't need that. And I'm going to use this to create a kite. So let's try creating a kite from here to here. And okay, and let's see, from here to here. Okay, so that's a kite. Okay, now where would my line of symmetry be for this kite? All right, so hopefully you realized if you fold or reflect across line BD that I just created, A is going to map perfectly onto point C, right? B is going to be where B is, D is going to be where D is. So that would be a perfect line of symmetry right down the middle. Okay, so that's an example of using objects to find their lines of symmetry. Let's see, what happens to the diagonal of a rectangle when the rectangle is reflected across the line of symmetry? Let's see, what happens to the diagonal of a rectangle when the rectangle is reflected across the line of symmetry? What does this suggest about the diagonals of rectangles? Let's find out. So I'm going to create a rectangle. Let's see, polygon, here to here to here. Okay, there's my rectangle. They were talking about diagonals, so I'm going to go ahead and show you. Like this is diagonal to this diagonal, right? And let me make sure I read this right. What happens to the diagonal of a rectangle when the rectangle is reflected across the line of symmetry? There are several lines of symmetry, aren't there? Is there more than one way to fold it or to reflect this rectangle? Like if I was to reflect across this line, right? That would be a line of symmetry. Now the diagonals, let me go ahead and create a point here so you can see it. Would A to G, right, this line segment map onto D to G? Okay. Would B to G map onto C to G, right, the line segment CG? So what do you notice? Now, is there another line of reflection or line of symmetry that exists on a rectangle? Okay, so hopefully you realized, yeah, if you reflect across this line, one side of the rectangle, the top side, will map onto the bottom part of the rectangle, right? So there's several lines of symmetry with a rectangle. And then what do you notice about the diagonals? Do they map onto one another or do they not? Okay, that's always a good thing to think about. All right, so in summary, symmetry. A shape has symmetry if there is a rigid transformation which creates an image that fits exactly over the original shape. So another great example is, let's say we have our rectangle, okay? Let me create a point in the middle, all right, in the center of the rectangle. Now, I'm gonna try a transformation. I'm gonna try rotation, okay, for giggles. So let's do a rotation around this center point. So I want to pick this rectangle and I'm going to rotate it around E. What if I rotate it 90 degrees counterclockwise? Does that map on? Does a rotation of that rectangle ABCD of 90 degrees, does that map on to the new image? Does that image map onto the original figure? No, right? I mean, it's on there, but it's not perfectly mapped on. So instead of 90 degrees, what should our rotation be? We tried 90, it didn't work. It was halfway there, right? So what's 2 times more than 90 degrees for rotation? 180? Oh, look at that. So skateboarders know this, right? If you want to be going the same heading after you do a cool, kick flip or something, and you're rotating that board, you got to rotate it at least 180, right? If you get hit 90 degrees, you're probably sliding down a pipe or something, right? So, skateboarders know this instinctively. All right. What if we did 360, right? So we got the rectangle. We're going to rotate around our point in the middle there, 360 degrees. And skateboarders already know. Yeah, you're going to go the same heading, right? You just flip your board all the way around. Okay, or rotate it, I should say, around. Okay, flip implies reflection, which is not what I'm doing here. Okay, so that's the end of lesson 15. Have a beautiful day.